Hello everyone, this is Shanko and welcome to chapter 1 of the microservices with Spring Boot tutorial. So in this chapter we're going to talk a bit about the monolithic architecture. We're also going to take a look at some of the problems with the monolithic architecture, and we're going to talk about the microservices architecture and look at some of its features. So let's get started. So a monolithic application is built as a single unit, and enterprise applications mainly have three parts: a database to store data, a client-side user interface consisting of HTML pages and or JavaScript running in a browser, and a server-side application. So when we are trying to build an enterprise application, most of the applications consist of three parts: a database, a client-side UI, and a server-side application that talks to both the UI and the database at the backend, right? And this server-side application handles HTTP requests, executes some domain-specific logic or business logic, and retrieves and updates data from the database and populates the HTML views to be sent to the browser. So oftentimes we deal with web applications where we have a UI, a user interface, where a user puts in some requests, maybe fills up a form and sends a request to the server, right? And the server fetches the response from the backend. The server fetches the relevant page or UI for the user, or the page, HTML page from the backend, and presents it to the user, right? So in a monolithic architecture, we have all of these and everything else that we can think of in the same place, a single logical executable. So in monolithic architecture, we have all these three components and everything that we can think of inside the same project, right? And they are deployed on the server as a single unit, or a single logical executable unit, right? And to make any alterations to the system, a developer must build and deploy an updated version of the server-side application. So even if we need to change just a single line of code, maybe for the UI, maybe an HTML tag that needs to be changed for a particular page, and for that we have to update the whole application, the all the components inside the application. We would need to update the application layer, we need to update the data access layer, we need to update the configuration layer, and everything that is present inside the application, because the application is a whole unit, right? So all the components for which there is no change also need to be updated, also need to be deployed again onto the server, because they are a single unit. So that is what monolithic architecture is about. And let's take a look at some of the problems with the monolithic architecture. So number one is everything is tightly coupled. This makes development of various components difficult, and maintaining these become a huge challenge. So there might be a person or a team working for the front end, working for the user interface, and there might be another team or another person who is working for the application layer that talks to the database maybe, and that sends the requests and the response, that receive the requests and sends the response back to the user interface. And because we have everything in the same place and all these components are tightly coupled, there becomes a dependency of one team on the other team for the deployment and for the development, because they are making use of the same application, or they're working on the same application, and it really becomes difficult to follow the agile methodology of software development, right? And the second point is even a single line of code change leads to a deployment of the whole system. So just as we have talked before, even if we need to change maybe a tag, a HTML tag for a certain page, that means we have to deploy the whole application, which consists of the application layer, the data access layer, the configuration layer, and the UI layer, right? The user interface layer. So everything is tied up in a single piece of application, and everything is tied together and everything is deployed as a whole system. So that is one of the problems with the monolithic architecture, right? And the next point is, it is not possible to scale individual components. So if there's a need for scaling individual components or individual parts of the application, it is not possible because the whole application acts as a single unit. It cannot be divided into granular parts, or it cannot be divided into parts which are smaller, because everything is tied together and we have a single unit that works as the application, right? So it is not possible to scale individual components. And the fourth point is, monolithic applications can evolve into a big wall of mud, a situation where no single developer or group of developers understands the entirety of the application. So this means that there's a certain team that works for developing the application, that develops the application, and that team leaves the company, that team leaves the organization, and the application becomes so huge with time that there is no specific team, or there is no specific person that has knowledge of the entire application in its entirety, because the application itself is so huge. It's not possible for a single developer or for a single team to know all about it, right? So it becomes really difficult for the teams to maintain such an application. And the fifth point is, it's difficult to achieve operational agility in the repeated deployment of monolithic application artifacts. So as we have already stated, it becomes difficult to achieve the agile methodology of software development using monolithic architecture, because the things are so tightly coupled that even if a component doesn't need any change, even if a component doesn't need a deployment, yet it has to be deployed, yet it has to be uh, changed, just because there are other parts that are associated with it, there are other parts that are attached to it, and the application acts as a whole. The application is a huge chunk that acts as a single application, that acts as a single unit, and that has to be deployed every time a small change is made in any part of the application, right? So those are some of the problems with the monolithic architecture. Now let's take a look at the microservices architecture and try to understand what microservices is all about. So microservice capabilities are expressed formally with business-oriented APIs. So microservice is an architecture which encourages the API first approach. Now what is an API? Let's try to understand what an API is. So suppose we have a functionality that needs to be performed. Suppose we need to add two numbers, right? Or suppose we have a system into which we feed two numbers and we tell the system what operation needs to be performed on those two numbers, and the system returns us the result. Now we as clients, we do not know how the system performs the operation, or what the system does to execute the operation or to fetch us the result. The system itself is a black box to us, to the client. But we are not concerned about how the system works and what the system does internally. What we are concerned about is the result, right? All we need is, we pass in two numbers to the system and we tell the system that we want to add these two numbers, or we want to subtract these two numbers, or we want to multiply these two numbers, and the system returns us the result. And we are not really concerned about how the system does the stuff that it actually does and gives us the result. So we are just not concerned about that the system is a black box for us. All we are concerned about is the result, right? So that is basically an example of an API. So what we do with an API is, we pass in some we're passing a request to the API, and we ask the API to execute certain tasks for us, or fetch us the result, maybe from a backend, or do some stuff for us with the data that we pass in, and the API returns us a response. And we do not need to know how the API works, or what performance or how the API works internally. All that stuff is not really necessary for us. We don't need to know about that, and the API itself is a black box to us. All we are concerned about is the result that the API returns for us, right? So that is an API, and they encapsulate a core business capability, and as such are valuable assets to the business. So each API is an individual component or an independent component or an autonomous component, right? And each API can exist independently and doesn't need uh, or doesn't really care about the existence of the other components. So each API is an individual component, and these APIs integrate or come together to make the whole system or the whole application. So as we had a huge chunk of different components tied together into one place in monolithic system, this is exactly the opposite that we are doing. We have individual components, or we have autonomous components coming together to build a single system or a single unit or a single application, right? And the implementation of the service, which may involve integrations with system of record, is completely hidden as the interface is defined purely in business terms. So we are not concerned about how the API works or what the API does. We as clients are only concerned about the fact that we pass in requests to the API, and the API returns us response. We are not really concerned about what the API does or how the API works, or what the API internally does to fetch us the results, right? The API is a black box to us, and we need not know about the internal functioning of the API. Okay, the positioning of services as valuable assets to the business implicitly promotes them as adaptable for use in multiple contexts. The same service can be reused in more than one business process or over different business channels or digital touchpoints depending on need. So a single API can be used in multiple places, or a single component in a microservices environment or a microservices architecture can be used by various other components or various other systems, right? And dependencies between services and their consumer are minimized by applying the principle of loose coupling. So in a typical microservices environment, we would try to identify the components that can exist individually, that can exist autonomously without having to worry about the existence of other components, right? And that is the principle of loose coupling that we try to achieve using the microservices architecture, right? And by standardizing on contracts expressed through business-oriented APIs, consumers are not impacted by changes in the implementation of the service. So the consumers are not really worried or not really concerned about the implementation of the service or how the API works internally. All they're worried about is the contract. All they're worried about is the request that they send in and the response that they get as a result of running the API, right? So there's a certain contract that is agreed upon by the client and the service provider. So when we are building APIs in a microservices architecture or in a microservices environment, we most often than not have a contract of the API, and we specify to the client what our header should look like, what a request should look like, what our request should be structured as, and what our response should look like, what our response should be structured as, right? And the client should not be worried about how we fetch the result or how we manipulate the data that we receive as request and return the response. They should not be worried about the implementation of the functionality of the API, right? All they should be worried about is the result or the request and the response, right? So that is what this line says. By standardizing on contracts expressed through business-oriented APIs, consumers are not impacted by changes in the implementation of the service. So even if the API changes the way it functions or the way it uh, works internally to fetch the result for the client itself should not be affected by that change, because it's an implementation change which is a complete black box for the client, and the client is only worried about the request and the response structures, right? And this allows service owners to change their implementation and modify the system of record or service compositions which may lie behind the interface and replace them without any downstream impact. So even if we are changing anything inside the API, which is a black box again to the client, it should not impact any downstream system, or it should not impact any client, right? And let's take a look at some of the features of a microservices architecture. So the number one point is services are encouraged to be small, ideally built by a handful of developers. So the development cost or the development time for a single component is really less compared to a monolithic architecture, because the services are independent and the services are really small, and managing them becomes really easy, and a team can have complete knowledge of a single unit or a single API or a single component which they own, right, in a microservices architecture. The next point is, if microservices interfaces are exposed with a standard protocol such as HTTP, such as RESTful API, they can be consumed and reused by other services and applications without direct coupling through language bindings or shared libraries. So we might have a system that only understands a front-end language, a UI language, a user interface language, and we might have another system that only understands database language, right, that is used to communicate with a database. And we might have another component that binds this two, or that joins these two or integrates these two components and makes the whole application, right? So we generally have our services exposed as RESTful APIs that can be consumed by other clients and that can be used by other services and applications without direct coupling through language bindings or shared libraries, right? And the next point is, services exist as independent deployment artifacts and can be scaled independently of other services. So there might come a time, or there might come a requirement wherein we would need only a single independent component to be scaled up, and after a certain time we might want that to be scaled down again, and this should not affect the other components, or the other components should actually be unaware of this scaling up and scaling down of the other of the independent component that they're trying to interact with, right? So that is possible in a microservices architecture or in a microservices environment, because the services are independent of each other and they are single units that can be deployed and that can be scaled up and down without affecting the other components or other units, right? So the next point is, developing services discreetly allows developers to use the appropriate development framework for the task at hand. So for developing the UI, we would need a specific set of skills and a specific set of developers that work with and that understand that know the user interface specific languages such as HTML, CSS, and those kind of stuff. And for developing another component, maybe for the application layer which talks to the backend or which has the data access layer, might require people who know about the application layer or languages that deal with the application layer, such as Java, Python, and such other stuff. And then we might have a backend system that interacts with these kind of interacts with these services or interacts with these units that understand another language. So that is another component. So we can have specific teams dealing with specific units. and using the right kind of framework or right kind of tool for building that particular unit, which is independent of the other units or of the other independent of the other teams, right? So in a microservices architecture or in a microservices environment, we would most often than not have teams with different skill sets, and there might be a team dealing with user interfaces, and there might be a team dealing with the applications and building APIs and stuff. So there are different teams for building different components or different units that come together to build the whole application, right? So those are some of the differences between the monolithic architecture and the microservices architecture. And in the next chapter, we're going to take a look at an architecture diagram for microservices architecture. So that is all for this chapter, and I hope you guys enjoyed this video. If you did enjoy, please give it a thumbs up. Thanks for watching.